Well, okay, everyone, let's kick this first webinar for the YouthAstroNet training sessions, training period of the last 2 weeks in October here for our 2017 cohort. I welcome you all here. I will be recording this video, so just be aware if you don't want I'm actually not recording everybody's video on screen, but if you don't want your voice recorded, you can use the chat box. So as you can see, I've shared the poll results. It looks like we have kind of a bell curve of astronomy comfort level out there, and that is great because we know that some people are coming to the project. You're intrigued because you think it might have something for your students, but you yourself might not have much astronomy background. And then it looks like we have some people who have quite a bit of astronomy teaching experience to share. So we're happy to have all of you here. Our team here at the Harvard-Smithsonian Center for Astrophysics includes myself. I'm the principal investigator of the YouthAstroNet project. And online with me today is Erica Wright, who is the YouthAstroNet community coordinator, and you've probably communicated with her most, and she's your go-to person should you have any questions. She's always monitoring the online forum, and if she can't answer the question, she can find someone who can. So also on our core team here at the Center for Astrophysics is Frank Sinkowitz. I think he'll be joining us online in a little bit. He's our robotic telescope network engineer. Aladdin Ibrahim, who is our IT specialist and does all the software programming for the online portal, which we'll talk about how to use today. And Harry Houghton, who is an education specialist on the team as well. Actually, it looks like Frank did just join. Right, he's right behind me, so he'll peek in. There he is. Okay. Now, all of you are represented on this map. It looks like we have educators from all over the country. So YouthAstroNet is truly a national program, and we're thrilled to have so many educators. This map actually includes our prior cohort of 50 educators or so, and it includes all of yourselves. And if you don't see your dot on this map, oh, actually there are two people, there's someone online that doesn't see their dot on this map. We have a couple of American international schools, one from Rio de Janeiro, Mary, welcome, and another from South Africa. So there are those couple dots aren't on this map, but if you are in the US and you don't see your dot, make sure we know, because we want to make sure we represent you when we're talking about all our educators. So just a few housekeeping logistics to at the beginning, which are, I think most of you have actually filled out your participation survey. Erica had sent you the link, and thank you for doing that. If you haven't done that, find that email from Erica and maybe even take it right now, because this first training webinar, if you take it after this first training webinar, it won't be quite as pre-survey as we'd like. At any rate, this also, many of you have sent your consent forms to our research coordinator, Annette Trenga, and if you haven't done that, if you can return that email as soon as possible. Okay, so today's live webinar kicks off a 2-week training session so that you can become an official YouthAstroNet educator and then enroll your students as YouthAstroNet youth participants. Today is the first of 3 live webinars. They'll all be recorded, so if this time doesn't work for you, or one of the other times doesn't work for you, you can view the recording on the online portal. And then the second webinar is this coming Friday, the third webinar on the 24th. Most of them will be about an hour to 75 minutes. I think we'll rarely have in a webinar that gets to 90 minutes. But in addition, you should be aware that Erica and Harry host live office hours, so that if after a webinar you go to try and do some of the activities on the portal and you get stuck, you can click on the Zoom link at any of these times, and Harry or Erica will be right there on the other end waiting to give you a personal tutorial if you're having any troubles, or to help answer questions. So essentially, to learn the program, these live webinars are here to help you. We have a whole online set of activities and some instructions for activities to do, so that you yourself learn how to use the telescopes. Oh, we have a question.
No, you got muted for a second.
Okay, am I back on? Yes, thank you, Erica. This week, you guys are the learners, and next week, we'll start having more discussions about how you implement this with students, although I know as educators, you're going to be thinking of that all along. So the core and most innovative resource of the YouthAstroNet program are the MicroObservatory network of robotic telescopes. So your students get to control these telescopes with no human in the loop, and get images back from them, and then they get to investigate those images, do projects of their own of various types. The picture on the left shows our two telescopes that are in Arizona. They're at the Smithsonian's Whipple Observatory south of Tucson, and these two telescopes are actually named Ben and Cecilia. We have 5 telescopes named after famous astronomers. Ben is named after Benjamin Banneker, first African-American astronomer, and Cecilia is named after Cecilia Payne Gaposchkin, who studied what stars are made of and what the sun is made of early in the 20th century. On the right here, you see Frank, our telescope engineer, with a group of YouthAstroNet participants from one of our local partner community centers at the Timothy Smith Network. So the telescopes are about 3 feet tall, as you see, and they are robots. And the way you and your students will control them is through the YouthAstroNet Portal. Now, a lot of you, Erica sent you accounts, has already enrolled you in both the Educator and the Youth Activity Portal. So I'm actually going to bring that portal right into view here. And actually, if you ever can't remember how to get to the URL for the YouthAstroNet Portal, if you remember MicroObservatory.org, that will bring you to our splash page where there's a lot of portals, but the YouthAstroNet password protected portal is right down here. So if I click on that, I get to my landing page, and as you all, many of you have already posted your introductions. Thank you. I've been really enjoying reading your introductions in the Educator Portal, and looks like someone else has introduced themselves since I've been on. You can see that I marked here with an unread post. Are people online seeing? Do they get this flag, or do they?
Might not yet.
They might not yet. Okay. Erica's going to change something in your settings so that you see when there's posts that you haven't read. But I wanted to show you a couple of things on the portal before we get to actually using the telescopes that might be useful. I know Erica's, a lot of you have started getting all the posts from people introducing themselves. And I just wanted to show you that there's a way to change your subscription so that you only get one daily digest email rather than an email every time somebody posts. And to do that, you would go to My Profile Settings, which I'm doing here. And can you see this? And you click on Edit Profile, and you'll see your username. And here where it says Email Digest Type, you see that I have no digest. I get a single email every time somebody posts to a forum. But I could change that to a daily digest, a daily email with all the posts people make, so you would only get one email a day. So I just wanted to point that out for those of you who are suddenly being overwhelmed with emails. There's a way to keep that from happening. And also to make sure you know that if you'd like to add a little icon of yourself or something that's a favorite food or drink or something like that as an avatar, you can edit your profile with that too, so we can get to know you better. So the YouthAstroNet Portal, whoops, as I said, includes the Educator Portal and then the Activity Portal, which is where your students will do all their work. So the Educator Portal is just for you, for both your learning during this 2-week period and for your follow-up when you have questions for us, or it's where all the curriculum materials are posted. So you can see that the top of the Educator Portal is mostly about this training workshop. And then as you move down, starting towards the end of these 2 weeks, you'll be ready to prepare for implementation, and there are lots of materials to help you get ready to enroll your students, to get them nicknames for the portal, and to prepare for so that Erica can make accounts for your students. All the curriculum, YouthAstroNet curriculum materials are here, along with tutorials and recordings of these webinars. Okay. So the first thing we're going to do is learn actually how to take a telescope image using the MicroObservatory robotic telescopes. And to do that, we have to get out of the Educator Portal. So I follow this breadcrumb trail back to the main page, and I go back into the Activity Portal. So this is where your students will do all their work. And you can see that there are some forums for students to participate in as well, and we'll talk about those as we go along. But the main activity that your students will want to know about is right here. This yellow square called MicroObservatory Robotic Tools. And we're going to go click on that now. And you'll see that there's 3 sections of the robotic tools. One is telescope image request. That's how you request images, how you send a message to our telescopes in Arizona. And actually we have one on the roof here in Cambridge and 2 in Frank's lab actually getting maintained. So through this is how you make a request. Those telescopes take the images you request that very night once it gets dark, and then the next day you find the images you requested here by clicking on this, and then you use the images and enhance them using this image processing tool called JS9, and that's what I'm going to show you how to do today. So first we'll go to the image request page, and you'll see that basically these are all the targets that your students can request images of. And at any given time, there's 3 to 40 different targets they can request. Although sometimes there's targets that are not up, either because of the season, actually always because of the season or the time of year. So Jupiter isn't visible during evening hours at the moment. So let's choose the, the other thing to note about this interface is that the targets are ordered in the same way that the universe is ordered. So there's a little bit of learning even in choosing targets. So these targets are all within our own solar system. stars and nebula are all outside of our solar system. And a lot of students have the misconception that there's more than one star, our sun, in the solar system. They think of the solar system and the galaxy as being kind of the same thing, that it's all the universe. So our targets are set up the way the universe is set up. The solar system only has one star, that's the sun. All the other stars and nebula that you can take images of are actually in our own Milky Way galaxy. And you can, taking an image of the Milky Way is not by getting outside of our galaxy, but taking an image from the inside of that band of stars that we see because we're inside the Milky Way. And then you can take pictures of galaxies far beyond with our telescopes. So I'm going to choose the Crab Nebula here and click Observe. And when I do that, you see that I have, I've chosen that target, and I have 3 settings that I have to choose to send to the telescope. So I want to just explain what you're telling the telescope to do for each of these 3 settings before I choose them. And we'll go back to my slides for that. So that first setting was field of view. And the field of view is selecting how the camera, there's actually 2 cameras on the telescope, and selecting how the camera works with regard to how big a chunk of the sky your image coming back will cover. So the normal view, as you see on the right here, is 1 degree. Well, what does that mean? If you hold your pinky fingernail out at arm's length, anything that any patch of sky that you cover will be a 1 degree field of view. In other words, this angle from the top of your pinky fingernail to the bottom of your pinky fingernail is a 1 degree angle. Whereas you can also take a wide view using the finder camera of the telescope for some objects, not all objects. Typically the normal view is the one you want to choose. So that's one setting. The next setting of the telescope is exposure time. So you're going to choose how long to let light fall on the detector of the telescope. And the MicroObservatory telescopes are imaging telescopes. You don't put your eye up to them. They have a digital chip, digital detector, and in fact telescopes are the origin of the technology that's now in all of your students' smartphones and cell phones. But these detectors in the telescope are sensitive to very, very dim light. And the dimmer the object, the longer you want the shutters to stay open. And so you make that choice. So then the third setting that you get to choose is to set a filter wheel. This is actually the guts of the camera in Frank's lab, this photo here, inside the MicroObservatory. And before that digital detector, there's a wheel with colored pieces of glass. So you can choose to have no filter at all, have the clear filter, have all the light from the object in space hit the detector, or you can choose to only let red light through, only let green light through, and so on. And at next Friday's webinar, we'll actually be talking in more detail about that, how to use those colored filters for good effect. But that is a choice that you make in sending your directions to the telescope. So again, here's a cutaway view of the MicroObservatory telescope. So the light goes in through the opening, and that's an important characteristic for astronomers. They like bigger apertures or openings to their telescope because they let in more light. The bigger the opening, the more light gets let in. And so MicroObservatory has a 6-inch opening. They're 6-inch telescopes, and they're reflecting telescopes because they use a mirror that's at the back of the telescope to reflect the light and they use mirrors to focus it towards the detector that's right up here. And here is that filter wheel that you set. Here is that shutter that you set how long it's going to open and let light through. And this here is the finder camera. If you choose that 10-degree field of view, the light comes in through this little 1.5-inch opening and gets focused onto this detector. All right, so let's go back to our portal and finish our request for that image. Okay. So again, this Crab Nebula only gives me one view, that one degree field of view. So I'll select that. Somebody just asked, are there objects you should use a smaller exposure time? Well, let's see if people want to type in the chat box for the Crab Nebula, which is a nebula is a cloud of gas and dust, and this is one that you cannot see with your naked eye. It's very dim. Do you think we want a shorter exposure or a longer exposure? Yeah, okay, we have a few people responding longer. Yes, exactly. So this is a dim object. If let's try 30 seconds. Up. The interface gives you a little hint. It says here, image may be underexposed. So in fact, for the Crab Nebula, we want a 60-second, a full minute, for that shutter to open and let light in to the detector. And Ginny, to answer your question, are there objects that should use a smaller exposure time? Let's look in a moment to, if you remember, well, we'll look in a moment at some objects and have you guess which ones might use a smaller exposure time. So then you have a choice of filter. I'm going to choose no filter. I want all the light as possible for this dim object to be let through. I'll click continue. And I get a little message here. The Crab Nebula was requested for M. Dussault. Click here. If I click there, I'll see my log. So here is the request I just made for the Crab Nebula. It's pending. I asked for the main camera with a 1-degree field of view, a 60-second exposure time, clear filter, and today is the 16th. These are all images I asked for earlier, which are in my account in the YouthAstroNet portal. So the nice thing about having an account in the YouthAstroNet portal is it keeps track of all the requests you've made and all the images. One thing you should be aware of, though, is that those images only stay in your account for 30 days. So if you haven't processed them or saved your processed image before 30 days and posted it into another part of the forum, you might have to take that image again. But there is a way to save it onto your hard drive as well, and we'll show you that at a later date. Okay, so I just took the Crab Nebula. I'm going to go back to the main page. I'm going to take another image of the moon. Now for this target, I can select, and maybe I want a zoom view of the moon. So rather than a 1-degree field of view, I'm going to zoom in on the moon and get a 0.5 degree. And actually, the moon might be a little too big for my field of view at that point. The exposure time for the moon, yeah, it looks like Mary made a guess here that the moon would be less exposure time. So let's try 1 second. Okay. And in fact, even 1 second is overexposed for the moon. So you're exactly right. The brighter the object, the shorter the exposure. And the moon is so bright that it actually requires a fraction of a second to not be overexposed. And not only that, we actually put a little bit of a gray filter over the moon. And notice we only give you that choice for this object because any other filter would let in too much light and that image would be overexposed. So I click continue. And again, if I go back to my log, now I have the moon and the Crab Nebula in my pending queue. So tonight, the telescopes are going to swing into action. They're going to take images of the things that all the YouthAstroNet and other MicroObservatory observers have requested. And Mary says, if the weather permits. Well, in fact, even if the weather doesn't permit, our telescopes will take images. That's one thing about the MicroObservatory system. As you saw those pictures early on, the telescopes are not in a dome. They're weatherproof. They're actually, the opening, the aperture is sealed with a plastic cover, and every time Frank sends them out, he seals all the cracks with silicone. And if it's cloudy, you'll get an image with clouds in it, as these two on the screen are. Occasionally, it'll be so cloudy that the image you get back will be blank. And so it's actually ends up being kind of a nice feature of the telescopes, is that students really learn what it takes to be an astronomer, that you don't always get good data, that, you know, sometimes, more rarely, the instrument fails, but often it can be cloudy. And that's one of the reasons we also have telescopes in both Arizona and Cambridge. It's frequently better weather in Arizona, and we have a background system that looks at images from all our telescopes and sends you the one that came out the best. Question came up, can you take an image for a later date? And in this system, you cannot. So it's day to day. Every day you take it. If you want an image that night, you go on to the portal, request it, and it'll be in your account the next day, but you cannot request it in advance the way our particular request system goes. So you kind of have to get used to getting on and making requests, but you can make requests for as many images as you want. You can request every single object in the target list every single day, and use that data. So, and you'll have that data in your account. So as I showed you in the portal, you have the telescope request interface. When you come back in the next day, you would get the images you requested. You'll see them by going to your image archive. And then the next thing we're going to do right on this webinar is show you how to process an image using our image processing tool. So let's do that. Let me get my YouthAstroNet account back in view. Okay, and you can see these images I just requested now on this webinar haven't appeared yet, but I requested some a few days ago on the 7th, and I have a few ways of finding those images. And you can see they were taken by different telescopes. So you can see which telescope sent back my images from a few days ago of the Crab Nebula. Ben sent them back. These dark images we'll cover in a future webinar. Those are calibration images for advanced image processing, but we'll talk about that later. These links are live. The one that says MO actually brings you to out of the portal to the to the MicroObservatory image archive, and where your image is in that archive. So you probably don't want to get too used to using that link, but if you want to know where the original data is, if you click on one of those links, it takes you to that image in the directory. Let me close that. Or you can click on the link of the image you want to look at over here, and it opens it up right in the JS9 browser-based imager. So I'm actually going to, let's take a look at this Orion Nebula image that I took a few days ago. I'm going to look at this one here. I'll click on that, and it opens in JS9. Okay, it opens the image right in the image processing tool. I'm going to show you another way to do that right now. If I go back and go to the main page, the other way I can do that is by going right to the image processing tool. Remember, use the images in JS9. So I'm going to click on that. And when I first open it, it doesn't know what image I want to view, so it's blank. And I have a few ways of opening images. Under my list, once you have an account, all of you, if you're in the, if you haven't taken an image yet, you won't see anything in this list. But remember, I had these Crab Nebulas and Orion Nebulas from October 7th, and so they're in my list. There's also a list of archived images that are in all accounts. And these are, if for some reason an image you wanted doesn't come out, or you're at your first meeting with students and or if I were on this webinar and I hadn't taken any images before, I could choose one of these images to demonstrate how to process it. But I'm going to go to my list since I did take some images, and I'm going to go to that Orion Nebula that I had before, and it opens the image in the image processor. I'm going to actually try and enlarge this a little so you can see things better. Does that help? One more? How about that? Okay. All right. So this is my image of the Orion Nebula. And as I move my cursor around the screen, I want you to really pay attention to what's going on here. There's some numbers changing down here, and actually up, whoops, up here. I'm going to move this over so you can see them. See these numbers changing, these numbers changing. So if anyone can tell me what that number here, this number here under pixel value, what it's here, oh, it went way up. Now it's in the 1400s. Now it's in the 400s. Now it's in the 300s. Okay, so I have a suggestion for one person for latitude and longitude for where I am in the sky, and another suggestion for light and darkness. Okay, and these numbers, yes, you pretty much got that right with a slight difference. So the number on the left, this pixel value, is the brightness of someone's annotating. Excellent. Yeah, is the brightness of the an indicator of the amount of light that fell on that pixel. And this physical location isn't actually the latitude and longitude in the sky, although for some telescopes it could be. It's actually, I want you to see that when I'm way down here, that physical location will be close to 0, 0. And when I'm up here, it'll be 0, whoops, what happened here? 0, 450. And when I'm over here, it's 650 and 450. So these numbers are not latitude and longitude, but are really X, Y, that they specify where on the detector the light fell. Let's take a look at a diagram of a piece of image data, just so you can figure that out. I'm going to bring my slideshow back over here. Where is it? Oh, I'm going to move that out. Yeah, okay. So the images that come back from the telescope, there really isn't an image. There's no film. All there is a data file with a bunch of numbers in it. And the detector, which remember looks something like this, has a bunch of light collecting sensors that we call pixels, picture elements. And the MicroObservatory detector actually has 650 by 500, actually, close to 500? Yeah, 650 by 500 pixels. Here's a diagram of a detector that basically has 10 by 10. And so this pixel, the values in that image processor, the pixel value would be 4, and the physical location would be 9, 2. Right? This pixel here, the pixel value would be 8. This is a bright pixel in this particular diagram where the numbers only go from 1 to 8, and its location would be 7, 3. It's XY location, or 3, 7, I guess. So the computer, the telescope only records a value based on how many photons of light came from that place on the target. And so in this diagram, the most light came here and 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 here, where they're 8, the value is 8. There's a few places in this image where it's a little dimmer. There's a really dark place in this image. Has anybody guessed what this diagram image is of? The target that's in these numbers, if you were to visualize and give shades of gray so that all the high numbers got white, all the low numbers got dark, and the medium numbers got gray. Right? We have someone, Ria, guessing it's a smiley face, and in fact, indeed. So these were the 8s, given values of very light gray. These are the 6s, which the computer gave values of medium gray. These are all the 4s, which the computer gave dark gray, and then the 1s here. So if you go back, right? And that's really all an image processor does. It's a paint by number. It visualizes the object and where the most light was coming and where the least light was coming. But you have control over how to display that and how to enhance that image. So I'm going to bring our image of the Orion Nebula back into view. And so if I use this tool called the pixel table, it brings up this little map of the data that's behind this image. So images from MicroObservatory aren't just pretty pictures, they are data. They tell you about the brightest places in an image. So as I move my cursor around this Orion Nebula, I see that these stars have a value of 4,095, and in fact, they were so bright that you see this strange spike, which is a, yeah, thanks for whoever's, are you doing that? Yes, thank you for whoever's annotating. Value of 4,095. Over here in the nebula section, the values are in the thousands, right? Over here, a little further out, we're in the high 300s. And way over here, we're around 360. Actually, the whole dark part of the image is in the 370s. So here's how we're going to use our tools. I'm going to close that pixel table to enhance this image of the Orion Nebula. Remember in our slides, we had the high brightness limit at 8, the low brightness limit at 1, so things colored 1 or things valued 1 or below are black, 8 or above are white. Here, anything whose value is 4,095, way over here, is going to be white. Anything whose value is 194 is going to be black. And values in between are given all these various shades of gray. Well, I have some values I know that are in here in these in the thousands, and right now they're colored dark gray. I want to boost them, so I'm going to lower my high brightness value. This is always the first thing you want to do to enhance your image and see if there's more detail. So I'm going to bring this down, and more and more and more of that Orion Nebula shows up. You start to see some things out here, but something else is also going on in that the background, remember, which is the background sky value here, also has some brightness to it. It's not completely dark. It doesn't have a value of 0. So if we want to enhance the contrast between the thing we're interested in, the Orion Nebula, and the background, I want to set this low brightness limit right here, this 194. The best thing to do is to set it at the value that comes up when you move your cursor in the darkest part of your image. And so I'm seeing values of 369. Let me set this at 369. And to do that, I just highlight. I can drag this, but it's much faster if I just highlight the number and type in 369 and hit return. Return. Whoa, much more contrast. And I can even bring that high brightness. So now I'm getting lots of these outer parts of the Orion Nebula. I can see this really fine structure. It's beautiful. Although I am kind of oversaturating the center here, and there's a way to not do that as well, which I actually will demonstrate next week. I'm going to leave it to you to figure out how to get you can get a much better enhancement of the Orion Nebula than I've done here. But I just wanted to show you that's what these using these two sliders are the first way to kind of manipulate. And again, you're not manipulating the background data, because remember, if I put my cursor up here, okay, the data is still all different, right? I'm getting values from the 800s to the thousands to that 4,095 where that bright star was. But because I've set my high brightness limit at 655, all those things are colored white by the computer. So this is not, if you were looking for the details in that central region, this would not be the best way to color it. I would want to do something like this so I can see all that detail, but now I can't see the dim edges. And okay, I'm just going to show you the trick for that because I can't stand not showing you the whole Orion Nebula. The trick for boosting really dim things without also boosting really bright things is to use something called log scaling. And I'll talk more about what that is in the future webinar, but let me just click on it and watch what happens to the Orion Nebula. Aha! Okay, now we're getting, and let me set that low brightness limit back to whatever it was, 320, 360, 360. Okay, so now you get a lot more detail of that Orion Nebula in the center and the outside. So there's a lot you can do. Oh, great question, Jenny. Can we practice on existing images without wrecking someone's project? Yes, you can do anything you want. and you will never wreck anything at all. What you do is only in your browser, everyone's work is saved on your local computer. It's not, you're not doing anything. The original data always stays the same. So that's the trick of image processing. Erica wanted to point something out.
With that point, if you don't save your image,
yeah,
it goes away.
Yeah. So I'm going to talk about saving images in a minute. So, but I certainly don't want to save this one I just did here. This is not something I want to save. But I might want to save that. You'll notice I had been using grayscale for my Orion Nebula, but you also have all these different color maps. And basically these are computerized color. They're really kind of like paint by number systems. There's where each different color map chooses different rules about what colors to map to what pixel values. So I like to actually start with this one, this rainbow 0, because instead of having, like, this Orion Nebula currently has 255 shades of gray that are representing, that's how many shades of gray a computer has, that are representing the Orion Nebula. I'm going to choose rainbow, which only has like 9 shades of color to represent, okay? And you can see if I bring this down or up, different things happen. And this limited color palette also is a good one to show these other 2 ways of changing your image, which I encourage you to explore, and which again will explain a little more in detail next time, which are these stretch and contrast adjusters. Watch what happens with the stretch. If I move it in one direction, it's actually squeezing the number of pixel values that the colors are spread over. And then I move it the other way and it's stretching. Squeeze, stretch, squeeze, stretch, squeeze, stretch. And then this adjuster shifts that set of colors towards lower or higher pixel values. So as I move this one way, if I shift to the left, I'm using those colors on lower pixel values, which is actually the outer parts of the nebula. So you see that being enhanced. If I move it to the right, it's shifting those to brighter colors, which is putting more emphasis on the interior part of this nebula. So why do you want to use these tools? All the adjusters are ways of enhancing the detail of the part of the image you're interested in looking at or measuring or figuring out something about. So image processing is something that helps you not only aesthetically create an image that you really like, but it also helps you highlight physical features of the image or features that you want to measure. And we'll talk about measuring as well later. All right, so that's a simple color palette. Here's one where you use a lot more shades of blue, green, and yellow, and I actually like this one a lot often. So there. So let's say this is the image I want to save for my project. To save an image after you've colorized it or enhanced it, you want to save it as a PNG image. Saving it the images that come back from the telescope are in a format called FITS. That's a format astronomers use. Telescopes from all over the world use this format, and in fact you can open images from telescopes all over the world in this JS9 image processing tool. And we're going to show you how to do that later as well. But images from our MicroObservatory telescopes are FITS images. And if you chose to save this as a FITS onto your hard drive, why would you do that when you already have it in your account as a FITS? Well, remember we talked about that 30-day limit. So you might want to save the raw data. So the FITS header, the FITS data is the raw data. And when you open that again, all this processing would be gone. You'd be back to your raw data. So I want to save this pretty image that I've just made. I save as a PNG. And it automatically names it. I'm going to put it on my desktop here. We'll save. And there it is. And I'm going to show you what to do with your image once you've saved it. Let's see. We've figured out, let me see where we're going here. We've figured out how to enhance an image, how to save it. And then I'm going to actually show you how to post it, because your assignment between now and our next webinar is to take some images yourselves, open them in the JS9 image processing tool, enhance them, create an image you like, save it as a PNG file, which I just did, and then post it on the Youth Astronet Educators Forum. So let's show you how to do that. I'm going to go back to the main page and actually go back. Remember, we're in the activity portal. We're in the youth portal right now. We want to go back to the educators portal. And here's your assignment, request and process an image. I'm going to click on there. And you see my call to respond. October 27 cohort, post your images here. And so I'm going to post my image first. I'll click on that and reply. Okay. Here is my image of the Orion Nebula. I used the, I think it was called Viridis color palette. And you might want to say some more things about how you processed it, but then I want to upload it. So I click on this little mountain icon right here. Don't attach it. Don't use the attachment. It works much better if you use this mountain icon, because then everybody can see it right in the forum post. So I'm going to click on that mountain. I find or upload the image, and remember I saved it to my desktop. So this is, I'm going to click on that, choose my file. It's from my desktop. And there it was, Orion Nebula, and it gives it this big long name, .png, that was it. Open that. And I'm going to upload that file. So there it is. I've uploaded it. You can add an image description if you want. And then click Insert. Okay. So there's my image. Now, if you want to insert a bunch of images into your post and you don't want them all so large, you can adjust the size of that, I think. Here, whoops. What just happened? I'm having trouble adjusting the size. Oh, yep, there. Thank you, Erica. I had to highlight it, and then I can make it a little smaller. There we go. So then I'm going to post that. And there it is. Your assignment, do the same thing. Reply to this post before the next webinar if you can. Okay, so let's go back to our presentation. The skills that you use in enhancing these images are the same skills and tools as the professionals use. In fact, that JS9 image browser is being developed for the professionals here at the Center for Astrophysics. We've adapted it to make it a little bit easier to use for novice learners, but the scientists who work with NASA's Hubble telescope or Chandra X-ray Observatory all use the same tools to enhance and colorize images they work with. And not only that, across the disciplines, image processing is really an important skill. Whether you're a medical interested in medical imaging, and there's a lot of the same enhancement of images from MRIs or X-rays or CAT scans. If you're a biologist, enhancing microscope images is a part of work in biology. If you're someone monitoring the energy efficiency of homes, you might use a thermal camera and you want to process the image to show which parts of the house are emitting the most heat. The weather images you see on the nightly news of hurricanes have all been processed using the same skills you use with YouthAstroNet. So the skills are the same, and to remind you of the kinds of projects that you get to do, the core elements are to help kids learn how to take lots of images with the telescopes, learn how to enhance them, and we've just done the kind of beginner's version of enhancing, and then to pursue projects with their images. And the projects could be astronomy projects, engineering projects, learning how image processing works, learning how light and color works. We'll demonstrate some of those later on, but I wanted to show you a few astronomy projects you could do right away if you're interested in them. If you are interested in if students are interested in investigating moon phases, they could take an image with the telescopes every night for a month and create a moon calendar. Jupiter's moons also move over time, so there's a lot of objects that if you take multiple images of, you can create even animations of those objects moving over time. Unfortunately, Jupiter isn't up right now. It will be in a few months, but you'll see that's not available in the telescope interface. You can observe sunspots. Now, the sun is the one image for which there is a human in the loop, because in order for our telescopes to be able to look at the sun, we have to manually put a filter to block a lot of the light. And Frank actually goes up and does that once each day. So when it's clear. So you only get your sun image back if it happens to be clear in Cambridge, Massachusetts on that day that you requested it. A really neat thing about MicroObservatory images, they're all at the same scale, which is not true of the images you look at in textbooks. You don't really have a feel for how big those things are in the sky. And one thing that does cause is that solar system objects end up being, except for the moon and sun, end up being a little bit disappointing for youth because they're so small. Here, for example, are 3 images of 3 objects in the solar system. And these are all taken by MicroObservatory telescopes, and these images are all the same magnification, same field of view. So now we know the sun is a lot bigger than the moon. Why does it appear the same size? And we know that Jupiter is a lot bigger than the moon, and it appears much smaller. Any hunches of what's going on? So in your MicroObservatory images, Jupiter is a lot further away than the moon, and so it appears much smaller. You can actually measure the the diameter, and remember this Jupiter was so bright that it got that overexposed spike. The actual Jupiter is here, and you can see the moons of Jupiter to the left of this. So you can measure the diameters of objects in numbers of pixels and calculate how distant they are. I'll show that in a future webinar as well. Yes, and this does help explain the eclipse exactly. So even though the sun and moon are very different actual sizes, their distance from us makes them the same apparent size in the sky, and you can really see that in MicroObservatory images. And you can even measure the change in the diameter of the moon as it gets a little further and closer in its monthly orbit. You'll actually see it grow and shrink, and you can measure that. Ginny asks if you can bring these images into Photoshop. You can, but you won't be able to do with them what you can in JS9, because as astronomical images, Photoshop won't, it's very hard to make Photoshop work with these FITS format images. If you save them as a PNG file, you can bring that image into Photoshop. Most educators don't have access. It's very expensive software, and it also can't do the kinds of measurement that we haven't really gotten into in this webinar in terms of measuring actual characteristics of the objects in space, measuring actual brightness of stars. Photoshop won't do that. Yeah, I would, yeah. So here's a bunch of objects viewed through MicroObservatory. Actually, and in our solar system, in our galaxy, star clusters, and galaxies beyond. And you can figure out their scale and realize that these things are really big in the sky. So the Orion Nebula is as big in the sky as the moon, or the Andromeda Galaxy is actually bigger in the sky than the moon, but you can't see it with your naked eye. So you don't realize that that object that's, in this case, thousands, or in this case, millions of light years away is huge. And so it appears big in the sky. So next steps, check out the portal, explore the workshop checklist, and by Friday, if you could introduce yourself on the Introduce Yourself forum, request some images from the telescope, process them, and post them. We'll take a look at your results, and I'll show you some new image processing steps on Friday, along with how to create a true color image, and we'll talk about the light and color aspects of viewing with the telescope. So with that, are there questions at this point? If people want to type any questions in, we can entertain a few.
Or unmute yourself.
Oh, or unmute yourself, yes. Feel free to do that if it's easier. If I need to watch this 4 or 5 more times, where is it? Yes, so this will be posted right in the forum. We'll put it, I think at the bottom is the section of, actually I'll put it right here.
Okay.
So if we're in the Educator's Portal and you scroll to the bottom, we have webinar recordings. And this is from from last year, but we'll put the one from today here as well. It'll be at the top. So the recordings are in here, and there are also video tutorials that show short pieces of what I demonstrated as well. So you don't have to kind of wade through the whole recording for that. In terms of giving access to your students, Mary, that happens after the 2 weeks of the training period, and we'll be going over that in webinar 3, and a special office hours session that Erica hosts for everyone who wants to get their students onboarded. So we give them accounts. They can save their files separately. They have their own account. They can, all their images will be saved in their own account space, and you as an educator have access to the accounts of all your students. Other questions?
If someone is hoping to get started right away, I want to show them where the consent form is just so that they have that.
Yes. Erica points out, if you're hoping to get your students started right away, you want to look in this preparing for implementation section. And in this materials for signing students up to YouthAstroNet folder. In here, there's a few things that we require before you can sign students up. One of which is we need you to get parental consent from the parents of students. Then we also need you to create nicknames for students, because we don't, on our online portal, we have no real names of students. We never know any personally identifiable information about them, and you have the key between their nickname and who the student actually is. So all that material is here. Erica personally helps every educator who wants to get this all set up. If you have questions, and we talk more about that in the future as we actually prepare for implementation.
There's a question about how long they can use this with their students.
How long you can use this with your students? This is an excellent question. Once a YouthAstroNet educator, always a YouthAstroNet educator. We hope that you will use it frequently and often. We have funding to keep the YouthAstroNet Portal going into 2018 and 2019 even. We may not be as active in the training seminars in 2019, but you can continue to sign up students and use the portal. There's a question, our Conklin, about district consent. If you could send an email to Erica, we can send you information about that offline. There are some school districts who, if the project is collecting pre and post survey data from students, and some districts have a process where they want to approve that, and we can work with you to help make that happen.
Thank you.
All right. Well, if you have more questions, remember that in the portal, there is there a general, oh, here we go. Questions about the portal, technical questions about MicroObservatory, and sharing your student capstone projects. That comes later when you want to share back to the community of educators. So please feel free to ask us questions online, and also when we get together again at next Friday's webinar. It's been great having you guys here. I'm so excited. Is there another question?
No, I was just going to say, go back to slide 2 so they can see the office hours again.
Ah, right. Thank you. So let's go back to slide 2, which were slide 5, office hours. So tomorrow from 4:30 to 5:30 Eastern time. I know everybody's all over the country, so you'll have to figure out when that is for you. Wednesday from 12 to 1 and 4 to 5 Eastern time. And Thursday from 12:30 to 1:30 Eastern time. If you click on this same Zoom link, Erica or Harry will be there to help you and answer any questions that came up as you were trying things out or exploring the forum. Those office hours are also posted here on the Educator Portal. right over here under upcoming events. So hopefully you have all that information, and we look forward to interacting with you and hearing your questions and hearing your discoveries and hearing your suggestions for how you can implement this with your students. So we're really, thank you guys so much. We look forward to continuing the conversation, and good luck, and we'll hope for clear skies this week in Arizona and Cambridge. All right. All right.
Looking forward to it.
Excellent. Thank you all so much. We'll end the meeting now. Bye-bye.
Bye.